Welcome back. So far, guys, we have learned 3 ways to solve a quadratic. We've done graphing, square roots, and then last time we did the method called completing the square. So those are the 3 we've known so far. And I told you a few lessons ago there are actually 5 different methods, which is a little extra, but hey, that's okay. Now, in Unit 7, which was all about polynomials, we spent a good amount of time factoring a quadratic into the product of 2 binomials. And guys, we kind of touched on factoring last lesson when we did completing the square. Factoring, so we've kind of dabbled in this already, factoring can help us solve quadratics. Now, before I show you how, there's something called the zero product property that we need to talk about before we get to the actual examples. Okay, zero product. Product means multiply. So this property says if 2 numbers multiply to equal 0, name makes sense now. If we're multiplying to equal 0, that means that at least one of the numbers involved has to equal 0. You already know we get mathy when we write a generic formula using A and B here, but we're saying if I've got 2 numbers, A and B, and I multiply them, A times B, and I get 0, then that means either A equals 0 or B equals 0. If you're multiplying stuff and it's equaling 0, one of those 2 things has to equal 0. Okay, so that's called the zero product property. Well, how does this apply to factoring? Let me show you. Let's remind ourselves how we factor something like x squared plus 5x plus 6. What we do, the thought process is, we're looking for 2 numbers that multiply to be the c value, in this case is 6, and add to be the b value, which in this case is 5. Some of you are real good at this and it jumps out at you right away. If you need to make a list of what multiplies to be 6, you can do that too. So 1 and 6, 2 and 3. Those are my options for multiplying to be 6. And the factors that add to be 5 are obviously 2 and 3. So I can rewrite this quadratic trinomial as 2 binomials, and it would just be xx, and I would say plus 2 plus 3. Okay, so on the left-hand side, I just factored this into x plus 2 times x plus 3 and set that equal to 0. Now, since the 2 binomials, these guys, are being multiplied, they're just sitting right next to each other, so they're being multiplied, and the product, or what it equals, is 0, we can apply this zero product property. So in this case, the A and the B would be these guys right here. So like x plus 2 is kind of acting like A, and x plus 3 is kind of acting like B. So therefore, using what this property says, one of these factors has to equal 0 if I'm multiplying them together to get a product of 0. So either x plus 2 equals 0 or x plus 3 equals 0. Or maybe both of them equal 0. I don't know. But I know at least one of them has to equal 0. So if I wrote these 2 equations as my 2 options here, when I solve both of these equations for x, that means I found the solutions to the quadratic. Yay! All right, I want to remind you of one more thing. In the first lesson where we were solving, I listed synonyms for the solutions to a quadratic, or other words they could use to imply, hey, we're solving. So they could say, find the solutions. They could say, find the x-intercepts. Because I know the solutions are where the parabola crosses the x-axis. They could say, find the roots. They could also say, find the zeros. And they say roots because like when we take square roots, you're finding the root. and zeros because it's where y equals 0. Fancy names, but they all just mean like solve this thing, find the answers. Okay, they didn't use anything fancy. They just straight up told me, hey, solve each quadratic. And they told me that I need to solve it by factoring. So I'm not completing the square like I did last time. I don't have to move the c value and make this a perfect square trinomial. I can just go straight into factoring and solve it from there. So here's how I would do that. I need to factor this quadratic trinomial into two binomials. So I've got to find the two numbers that multiply to be 16 and add to be negative 10. Okay, I didn't leave myself nearly enough space here, but I'm looking for factors of 16 that add to be negative 10. So let's see, 1 and 16, 4 and 4, 2 and 8. And guys, think about your signs. The two numbers have to multiply to be a positive, but add to be a negative. So if I only use positives, I'm never going to come up with negatives. And if they multiply to be a positive, both of these guys have to be negatives. So watch your signs. So the two factors that would add to be negative 10 would be right here. Negative 2 and negative 8. So once you've found the two numbers, you can rewrite this thing. Now I'm going to use this zero product property. So honestly, guys, this method is better than completing the square. Completing the square is just quite the process that's kind of difficult to remember. Factoring's not as bad. So zero product property says if you're multiplying two things and it equals 0, either the first factor has to equal 0. So I've got two options. I need to write two equations. Either x minus 2 equals 0 or x minus 8 equals 0. This is where my two solutions are going to come from. So I'm going to solve both of these guys for x. And this first equation, x would equal 2. And the second one, x would equal 8. So those are my two solutions. Okay, I want you guys to try example 2. So just straight away factor this guy and then use your zero product property. Now, I want to point something out about this example that I just did. The same thing is going to apply to yours right here. Notice that the answer signs, so when I found the two numbers, it was negative 2 and negative 8. Those are not the answers. The answers are not negative 2 and negative 8. The answers were actually positive 2 and positive 8, because you got to set them equal to 0 and solve. So notice that the answers signs, like the signs on the numbers that were the answer, are not the same as the factors signs. Meaning whatever you get when you factor it, the signs on your answer do not match, because you're eventually going to solve, so the signs are actually going to be the opposite of what the two factors were. So be careful. I see people every year, they find the two numbers and they're like, oh, those are the answers, negative 2, negative 8. But it's actually the opposite of those answers. Okay, so just be real careful. Just takes practice. Here we go. Okay, number 1 looks different. And it looks different because this is a binomial that I'm factoring, not a trinomial. If you see a binomial, that should be a hint to you. And guys, this uses tons of old stuff, so deepest apologies right now, but you got to remember a lot and apply a lot to be able to do this lesson. But if you see a binomial, that should be a hint to you that there's a GCF. Don't pay attention to the equals 0. I'm just trying to factor this guy. So x squared and 7x, those have an x in common. So I could pull that out front and write what's left over. So you would divide both of these by x to factor it out. And that would leave me with x minus 7. Factoring, guys, just means what can you multiply together to equal this quadratic. In this case, it's x times x minus 7. Once you've factored it, you use the zero product property. So these are the two things that I'm multiplying together to equal 0. That means one of these factors has to equal 0. So either x equals 0, the first thing, or x minus 7 equals 0. So I've got to set both of those guys equal to 0 and then solve them. This one's already solved. X is already by itself, so that's one solution. This one, I got to add the 7 to both sides, and that would give me x equals positive 7 as my second solution. Okay, let me do another one. Now, something to point out about factoring. You always have to end by using the zero product property. Okay, so that means that this equation has to equal 0. Huge note to make right here. To use the zero product property, the equation must equal 0. So if it doesn't start out equaling 0, it starts out equaling 12. You need to move the 12 over, so that way this equals 0. Otherwise, the zero product property is not going to apply, meaning I could not solve this using factoring. Okay, the rest of them equal 0, so those are okay, but if they're asking you to use factoring, it must equal 0 to be able to use the zero product property. Okay, now I'm going to go ahead and factor this. There's no GCF. This is a quadratic trinomial, so I'm going to put it into two binomials. And I'm looking for two numbers that multiply to be negative 12 and add to be positive 1. If you need to come over here and make a list. If they multiply to be a negative, the signs are different. One's positive, one's negative. They need to add to be 1. Okay, it's 4 and negative 3. Those multiply to be negative 12 and add to be 1. I'm going to fly through that factoring part just because that's an old skill. You guys have learned this before. I'm not assuming that everybody remembers everything about factoring, but if you struggle with this skill and need extra help, you got to ask in class. Okay? Once you find the two numbers, plug them into your parentheses here, use the zero product property. So x plus 4 could equal 0, or it could be the x minus 3 that's equaling 0. Then you got to get x by itself in both of these. The signs will switch, so it's actually going to be negative 4 is one solution, and positive 3 is one solution. Keep in mind, guys, that you can check your answers. So I'll just check one of them. I got negative 4 as an answer. That means I'm saying that I should be able to plug in negative 4, and it should equal 12. And it does. I should be able to plug in 3, and the same thing happens. All right, so let's keep going. Okay, here's where it gets real. So there's no GCF here. It's a good thought to have right from the beginning. But here's what I notice, what's different. On 1 and 2, in the example from the front, the A value was 1. Right here, the A value is 4. So remember when we did these factoring problems that we had to do a little bit more work. We had to guess and check. And remember to start it. Again, this is an old skill. I didn't think about the 20x in the middle. All I did was I guessed and then I checked it. So the first two terms when I factor should multiply to be 4x squared. So we broke up the x's. You could have either used 1 and 4 or 2 and 2 to get 4. And remember, I always suggested that you choose the factors that are closest together. So 2 and 2. And then these guys should multiply to be 25. So I could do 1 and 25, or I could do 5 and 5. And again, remember, I always suggested to pick the factors closest together. And then we checked it. So if you remember, I know 2x times 2x is 4x squared, and 5 times 5 is 25. So you really only have to check the outsides and the insides to make sure we come up with 20 x's. So that would be 10x plus 10x, which 10 plus 10, yep, that's 20. So that means I got it right. Yay! If we wanted to write the whole thing, we could. So that was called guessing and then checking to make sure it's right. If the A value is not 1, you have to guess and check when you're factoring. But once I've factored it correctly, like I did here, then I do the zero product property. Notice these factors are the same, guys. So when I set them both equal to 0, it's going to be the same equation. So I really only have to write one equation and then just solve this guy for x. So I would subtract 5 and then divide by 2. Decimals are not illegal. There's only one solution, and it's -5 halves. Sure, you could write it as a decimal. I'm going to keep mine as a fraction. All right, let's do another one. So this sucks because that's a lot of work, not going to lie. It will always benefit you guys to think about GCFs. Like, yeah, it's still a trinomial, but if you analyze 3, 21, and 36, 3 goes into all of those. You'll make your life a lot easier if you can pick out a GCF on the factoring problems. I could divide all these guys by 3. So that means I can pull a 3 out front. If I divided all these by 3, what would be left would be x squared plus 7x plus 12. Now the 3 is out of there, so don't even worry about it. I just have to factor this quadratic. So two numbers that multiply to be 12 and add to be 7 are 3 and 4. You don't have to do anything with this 3. It's totally irrelevant now. But you do need to just carry it down front on your answer, but don't do anything with it. It's totally irrelevant. When you do the zero product property, like doing 3 equals 0 makes no sense. So don't even look at that. You just do x plus 3 equals 0 and x plus 4 equals 0. So when you solve those guys, you get -3, -4. All right, this one looks different. There is no GCF. There's nothing that goes into 9 and into 16, but I can rewrite this to kind of make more sense. It looks different because the x's are gone. There are 0 x's. So I could rewrite this guy and then think about factoring it. You did guess and check here. The first two slots have to multiply to be 9x squared. So I'm going to try 3x and 3x. The second two slots have to multiply to be -16. So I'm going to go with -4 and +4. And then we could check it to make sure it works. So outsides and insides, let's see, that'd be 12x minus 12x, which, yep, that's 0 x's. So here are my two factors. I want to set them both equal to 0. When I solve these, and to take care of time here, guys, you're going to add 4 divided by 3. So the first answer would be 4/3, and the second answer would be -4/3. That's not a nice answer, but that is right. Okay, leaving you with that one. See what you can do here. You got to guess and check on this one. Now, let me point out something, because the next lesson, we're going to do the very last, fifth and final method for solving a quadratic. Realize I'm not going to give you one like number 5 and tell you to solve it by factoring. The reason is because number 5, you could have actually used a way quicker method. You could have done square roots. When there's no b term, there's 0 x's. Remember, we just add 16, divide by 9, and then square root. So you wouldn't have to factor on number 5. Also, let me point out that like the ones where you have to guess and check, that sucks to do factoring. That takes forever. So there's actually another method that we can use really on any of these, but specifically ones where factoring isn't ideal because it kind of takes a while. So number 6, yeah, you're going to solve it by factoring, but there's another way that I'm going to show you next time that might be better than factoring for number 6. Let me show you real quick one more example of like a word type problem, application problem that you might see on your exam. So it says the length of my desk is 3 feet more than its width. Here's my desk. It's a rectangle. I should probably say that. That should be given. The area of my desk is 28. What are the dimensions? Okay, dimensions mean length and width. I want to find both numbers. First thing I would do is label the picture. So the length of my desk, which would be here, is 3 feet more than the width. So I could rewrite, and I'm going to write a sentence or an equation from this sentence. The length, so L, if you don't know this, is means equals. So the length equals 3 feet more than the width would be like W plus 3. So if I come to my picture here, I'm going to label the width just W. In the length, instead of putting L, I'm going to put what L equals, which is W plus 3. This is a good old first semester problem coming back to haunt you. So my goal is to label my rectangle using just one variable, which I've done that here with W. I know the area is 28. So let's see if I can find the length and the width. Think about how you find the area of a rectangle. You do length times width. So in this case, it would be W times W plus 3 equals 28. Okay, so if I distributed the W here, I'd have W squared plus 3W equals 28. This is in the factoring lesson. So let's solve this by factoring. If you're doing factoring, it has to equal 0 to do the zero product property. So I'd subtract the 28 over, get everything on the same side. Continue this up here. So it'd be W squared plus 3W minus 28 equals 0. Let's factor this guy out. So I'm looking for two numbers that multiply to be negative 28 and add to be 3. Well, those two numbers are going to be 7 and negative 4. Then I could do the zero product property. And when I write my two equations and solve, I get negative 7 for the width and I get positive 4 for the width. Obviously, in my desk, there's only one width dimension. And if you analyze the two options I have right here, and we're going to see these a lot in these application problems, you cannot have a desk that has a width of negative 7 feet. That makes literally no sense. So you got to throw that answer out. It's not the one I want. I want the positive answer. The width would be 4 feet. Okay, they also wanted me to find the length. So come back to your picture. If the width is 4, you could plug that in here, and then the length would be 4 plus 3, which would just be 7 feet. So width is 4, length is 7.